Yeah, would you able to see the screen? PPT?
Yes, sir.
Yeah, okay. Good morning. Let's continue with the last class. In last class, we just closed off the integration chapter, okay, with the functional unit of a robot. Then we have started with mechanical actuation system, basically. Now, I think when we have started with the mechanical actuation system, before that, we had discussed about the concept of the actuation system. What do you mean by actuation system, and what are the various different types of the actuation system? Okay, with this, we have started with the mechanical actuation system, and I think we have discussed about the concept of mechanism. And basically, the mechanism is nothing but the devices which are called as the motion converters. Okay, so they are going to transform the motion from one form to another form. Okay, maybe from as we are discussed in the last class. Okay, with examples we have discussed, maybe from linear to rotary. Okay, or vice versa, or rotary to intermittent rotary, or rotary to rotary. Okay, or linear motion to linear motion. Okay, that is by using the linear joints. Okay, so that is what we have discussed. Basically, the mechanisms are nothing but the motion transmitters, right? Then earlier, okay, earlier mechatronic system, we used to have the more of a mechanical component, but with the invention of the microcomputers, so we have started to use microprocessor as the controllers for controlling the mechatronics system. Okay, right. Then other than that, we also can use the mechanism for force amplification, change of speed, and for the other purpose. Okay, I think we are somewhere here. Okay, right. Now, when we are dealing with these mechanisms, okay, so generally we have two different cases which are going to be there. One is called as what is called as kinematics. Other one is called as the dynamics, right? Now that is the chapters. That is the subject that you had discussed in your earlier semesters, called as kinematics of machines and the dynamics of machines. Okay, right. Now basically we know that the kinematics is the one, okay, where you are going to study the motion of your mechanism without the application of the forces. Okay, so without the presence of the forces, you are going to study about what is called as the application of the force, and that is what we call it as the kinematics. Okay, on the contrary, we have what is called as the dynamics, wherein we are mainly dealing with the application of the force analysis. Okay, now with the amount of the force or with the type of the force, what is the changes which are going to happen, okay, in the mechanism structure is what is going to be dealt in dynamics. Contrary, in the case of kinematics, we will not be considering what is called as the forces, right? Now that is what is the meaning of this here. Now about the kinematic differences between kinematics and that of the dynamics, right? Now when we say about the motion, okay, in the mechanical system, the first and the foremost thing is to understand the various different types of the motion, the links, the or the joints are going to have. Okay, now when it comes to the types of the motion, okay, basically it has been classified into the two broad cases. One is translation motion and other is the rotational motion. Okay, now you can understand the translation motion, movement which can be resolved into components along one or more of the axis, right? Next is the rotational motion. One second. Class ಎಷ್ಟೊತ್ತಿಗೆ ಬರೋದಪ್ಪ? ಹೌದಾ? ಬಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತಾ? Rotational motion, okay. Rotation which has components rotating about one or more of the axis. So that's called as the rotational motion. Now these are the two cases which are going to be present with respect to the types of the motion, right? Now, when it comes to the degrees of freedom, okay, with respect to the constraints, okay. So freedom and constraints. Now in mechanical system, basically, the basic aspect of your mechanical system is the freedom and the constraints that you are going to give for the purpose of giving a 6 degrees of freedom. Okay, right. Now the important aspect in the design of mechanical system is the orientation and arrangement of the elements and parts. Then a body that is free in space can move in 3 independent mutually perpendicular directions and rotate in 3 ways about those directions. Okay, that means here in case of the mechanical systems, okay, basically what is important for us is the movement of the links, okay, in the various different directions. Okay, right? Now those movements we call them as what is called as the degrees of freedom, okay? And each degrees of freedom, okay, is going to be dealt in this particular section here, okay? Now generally it's going to have 6 degrees of freedom. The degrees of freedom is nothing but the number of components of motion that are required in order to generate the motion, okay? In order to generate the motion, how many number of components of motions are required, okay? That is what is called as the 6 degrees of freedom, okay, right? Then freedom and constraints. Now if you observe these two diagrams, okay, we can observe what are the various different types of the degrees of freedom. Now if you just go back and observe, now in this case of the figure A, now we have what is called as x, y, z. Now all the degrees of freedoms are going to be associated with what is called as the linear system, okay? Now in all the cases, the links can able to move linearly from one point to and from one motion to another location, okay? That is about the linear system. On the other hand, we have what is called as the rotational system. That is the possibility of rotating about the same axis is going to be there. So that is called as the rotational system, okay, right? Then now in this diagram, we can observe that one translational degrees of freedom, that is figure A, indicates the translational degree wherein the link, the two corresponding links are going to move with each other. And figure B shows a joint which has one translational degree of freedom and one rotational degree of freedom, okay? So one translational and one rotational, okay? So that is the case, right? Now with this approach, okay, we'll try to go with what is called as the kinematic chains. Now in the kinematic chains, okay, now we have discussed what is called as one second please. Right now, okay, yeah, sorry, right now we are just discussing about the degrees of freedom, and then we'll try to understand what are called as the kinematic chains, okay, right? Now in the kinematic chains, okay, so basically now we have individual diagrams here, okay, so which represents what are called as the various links, okay? Now we understood that in case of kinematic chain, it is mainly what is called as the motion transmitter, okay? So we will be transmitting the motion from one to another, okay? So motion transmitter is what is the main important thing. When we are going to transmit the motion, from how are we going to transmit the motion is what is important, okay? Now which member, okay, is basically used for the transmission of motion, okay? Now we know that there is something called as a rigid body, okay, a rigid structure which transmits the motion, and that rigid structure is what we have termed as the link, okay? In all the earlier discussions under the kinematics of machines, so we call that as what is called as a link, okay, right? Now each part of a mechanism which has motion relative to some other part, okay, so the motion relative to some other part is what is termed as a link, okay? So as we have discussed, link is a rigid body. Now in order to transmit the motion, there should be what is called as a point of connect between one link to another link, and that is going to be through what are called as the nodes, okay? So when this node is going to join with this, okay, so we have developed what is called as a, now this is going to be something like this, okay? If this is going to happen, okay, right? Now this is again a node which is going to connect here, and this collectively is called as your the joint, okay? So this is what is called as your joint. Joint is the combination of or the connection of the two nodes, okay, or superimposition of the two nodes which joins the two different or which transmits the two different links, okay, right? So a rigid body which has two or more points of attachment to other links is termed as nodes, okay? Now each link is capable of moving relative to its neighboring links, okay? Obviously that is what is the purpose of a link all about, or the kinematic link all about. Now then a joint is a connection between the connected links at their nodes which allows some motion between the connected link, okay? As we have mentioned, a joint is nothing but a connection between the links, okay? So this link, so we have link number 1 and link number 2, and the joint is the connection through at their nodes. Okay, the joint is going to happen only at their nodes. Okay, right. And if you consider the various different kinds of kinematic links, now we have levers, cranks, connecting rods, pistons, slider, pulley, belt, and shafts. Okay, these are all the example of the links. Okay, now if you observe, depending upon how are you going to transfer the motion, okay, we have what is called as the various different nodes. So we have 2-noded link, 2-noded link, 3-noded link, and the 4-noded link, which are going to be in okay, which are going to be considered for the kinematic chains. Okay, right. Now this is about what is called as a concept of a kinematic chain. Now a simple example is going to be there here to illustrate the working of a kinematic chain. Okay, now here a sequence of joints and links. Okay, again a continuation. A sequence of joints and links is known as kinematic chain. For a kinematic chain to transmit motion, one link must be fixed. Okay, so movement of one link will then produce predictable relative movement of the others. Okay, right. So movement of one link will then produce predictable relative movement of the other. Okay, that is with a fixed link. Okay, and you can make the other link to move in a known manner depending upon what is the type of motion that you are going to give. Okay, is it a translation motion or is it a rotary motion? Okay, right. Now it is possible to obtain from one kinematic chain a number of different mechanisms by having a different link as the fixed one. Okay, now that is what it says. It is one here, one is fixed one. Based on one, you can have a different combination. The design of many mechanisms are based on two basic forms of kinematic chain, that is 4-bar chain mechanism and Schrader crank chain mechanism. Okay, now here the example what has been given is the reciprocating motion of a piston within the cylinder. Okay, so how the movement is going to occur, so that is what has been given. Okay, so indication is crankshaft. Now the number 3 is going to be your the fixed frame. Okay, now this slider is going to move with the rotation of the crankshaft with the connecting rod. Okay, the connecting rod will use the motion to the slider to go up and down within the cylinder. Okay, so it's a simple understanding for an example for a kinematic chain, how kinematic chain is going to be, it can be built. Okay, right. Then we have what is called a 4-bar chain mechanism. Okay, right. Now in 4-bar chain mechanism, okay, we have double lever mechanism, lever crank mechanism, and double crank mechanism. Okay, right. Now here, with reference to these links, okay, there is one particular law which is associated with respect to this. Can anybody recall that law? Depending upon the length of the link, can I get the linear motion or can I get the translation motion, something like that? Can anybody recall that law? Let me check. Okay, so we have 15 members. Can anybody recall? We have only 13 members. Can anybody recall what is called as the law? Okay, which states about the length of the links. Okay, some if the length of the shorter link, length of the longer link, something like that. Can anybody recollect? Yes or no? The length of the square of the two shorter link should be less than, if it is less than or equal to length of the square of the longer link, that is called as something called as Grashof law. Okay, I think probably you might have forgot. That's not an issue. Okay, so there is something called as Grashof law. Okay, so based on the Grashof law, okay, now depending upon the length of the link, okay, depending upon the length of the link, okay, we will be getting the link may be a translation motion or a rotary motion. Okay, now just to recall, so we have double lever mechanism. Okay, in this lever number 1 and lever number 4, okay, with any extent of movement, okay, so this is fixed. Okay, so lever 3 is going to be fixed. Okay, with any extent of movement, so you can only have maximum, you can only have the translation motion. Okay, so up till here you can come. Okay, means you can't have a rotary motion. So that is because of the length of the link. Okay, now here if you observe, so 1, okay, 3, 2, and 4. Okay, now here in lever crank mechanism, okay, now 3 is fixed. Okay, 3 is fixed. and with the motion, okay, I can have one as the sliding motion, and 4 can take what? The 4 can take one complete turn. Okay, that means with this mechanism, 4 can take one complete turn. Okay, that is rotary can be possible, and this is going to be only what is called as a translation motion. Okay, right. Then next one is a double crank mechanism. Okay, double crank mechanism. In this case, both 1 and 4. Okay, both 1 and 4 can take a rotary motion. Both 1 and 4 can take a rotary motion, provided the length of the 2 and 3 is going to be same and 3 is going to be fixed. Okay, now based on the length of the links, so you can have double lever mechanism, lever crank mechanism, or double crank mechanism. Okay, now these are all the 4-bar chain mechanism which are going to be present. Okay, right. Then yeah, leave it. Okay, right. Now in this another 4-bar chain mechanism. Okay, now there is something called as an example. Okay, just an example to show the tailgate in toggled position. Okay, what do you mean by toggled position? Okay, that we'll try to understand. Okay, it says some linkages, right? Some linkages may have, right? Some linkages may have toggle position. Okay, now what do you mean by toggle position? So these are the positions where linkage will not react to any input from one of its links. Okay, now basic concept of the link is what? Basic concept of the link is it transfers the motion from one link to another link. Okay, so the main aspect of the link is it transfers the motion from one link to another link. Okay, but if it has achieved, okay, if it has achieved a toggle position, if any combination of the link, if it has achieved a toggle position, in that particular position, that linkage will not go into move. Okay, will not go into move, even though the other link is going to give a motion. Okay, so that is called as a toggle position. Okay, now in this case, okay, so figure below illustrates such a toggle. Okay, being the linkage used to control the movement of the tailgate of a truck, so that when link 2 reaches the horizontal position, no further load on link 2 will cause any further movement. Okay, now he says, so now this is the link. Okay, so this is a truck body. Okay, now it is giving a motion. Now when the 4 is going to move, okay, when the 4 is going to move, okay, then 4 transmits the motion to 3. Okay, link number 3, and through that link, the link 2, okay, which is a larger link, okay, through this is going to move. Okay, now it is going to come down. Okay, something like this. Okay, right. When this 2 has reached an horizontal position, okay, right, please observe, when the link 2 has moved in horizontal position, 4 has completely extended, means completely given the motion, which has transmitted completely to 3. Okay, now in this case, okay, link 2 cannot move any further. Okay, so link 2 cannot move any further because of what is called as, now you just observe, all of them are going to be in the straight line, and also it is going to be what? A firm and fixed. Okay, now this position, okay, this position of the link is what is called as the toggle position. Okay, so other possibility is what? Other possibility is wherein 3 and 4 is going to be in the vertical. Okay, there is another toggle position for the linkage, that is when links 3 and 4 are both vertical and the tailgate is also vertical. That means the whole thing is going to come like this. Okay, the whole thing is going to come like this. Okay, now this is going to become your 4. Okay, first I'm just drawing this 4. Okay, so this is going to be your 4, followed by what is called as 3. Okay, right, then followed by what is called as your number 2. Okay, so all this is going to be in the straight line arrangement. Okay, all this is going to be the straight line arrangement. It is 4, 3 and 2. Okay, all this tailgate in the straight line arrangement. This is called as a toggle position. Okay, right. Now these are all the examples for the what is called as kinematic chain. Okay, so when we have discussed about the kinematic chain, so it is just the movement of the linkages. So two cases, one is called as your the 4-bar chain mechanism, other one is going to be slider crank mechanism. Okay, now if you observe a slider crank mechanism, only the figures are going to be there. Now you can observe this indicates from point A to point I, it indicates the position, okay, position of the linkages. Okay, right, in all the different movements, the position sequence for the links in a slider crank mechanism. Okay, now this is, and just observe, this is going to be your starting point, okay, and this is going to be your ending point. Okay, so the movement is going to start from here, okay, and it is going to be end by which this link, okay, let me take this link as number 1. This link has completed 360 degrees of rotation, as simple as that. Okay, so this one number, link number 1, okay, only from here to here, only from here to here, has completed its motion throughout this, which is 360 degrees. Okay, now this is the starting point. Okay, now the link position is going to be here. Okay, now once it just start to rotate, that means, so this link, okay, so when it comes here, okay, that is something given here, then it is going to pull this to the left. Okay, when it pulls this to the left, so this link or this joint, whatever, or the node, we can say, is going to come very closer. Okay, now as and when it comes, now it is, let's say it's 30 degree, okay, right, then it is going to be 90 degrees. Okay, then the node has shifted to the left, still left. Okay, and then another 90 plus 35, it is still left. And when it comes to the horizontal, that is from 0 to, now here it is 0, let me say, and then here it is going to be 180 degree. Okay, now it has traversed half of the speed. Now from here to here, okay, so it is somewhere at the center. Okay, now this node has come to this, okay, point with a rotation of this lever, this link, by an amount equal to 180 degrees. Okay, then again what is going to happen is, then again the rotation is going to occur. Okay, so now it is going to be what, the another half. Okay, with another half is going to be there, then I am just pushing this to the right. Okay, so in one sequence we have pushed it to the left. Okay, and in the next sequence then another 180 degree downward, another 180 degree, so we are pushing this onto the right side. Okay, now that is what is happening here. Okay, 180 plus something, so just the node started to move to the right. Okay, so this is totally 270. Okay, 180 plus 90 this way, and this is 270 plus, and this is 360 degrees. That means this link has took one complete rotation. Okay, by which you can able to understand the movement of the nodes accordingly. Okay, so that is a basic concept of what is called as a slider crank mechanism. So now these are the two different kinematic chains, okay, which are going to be present. Okay, right. So basically, when we have discussed about the kinematic chain, okay, so first remember about what is called as a degrees of freedom. Okay, so kinematic chains are the links can able to have any of the 6 degrees of freedom. Okay, right. So 6 degrees of freedom, 3 linear movements and 3 rotational movements. Okay, that is called as the concept of degrees of freedom. Then the link can able to have the link should supposed to give the movement, okay, which is through the nodes and through the joints. Okay, so that is how the movement can able to occur, and how the links are going to be there. So we have gone through with 2 different cases, that is 4-bar chain mechanism and the tailgate, that is the toggle position we have discussed, and then slider crank mechanism. Okay, so this is one such actuation system, which are kinematic chains. Okay, right. Now other actuation, the mechanical actuator, okay, which is more or less largely used, okay, for the precise location, or for the precise movement, okay, it was called as the cams. Okay, now let's understand some quickly the issues regard to cams. Okay, now in this case we are not interested to draw the diagram of the cam. Okay, we are interested only to know how what is this cam, and with respect to the actuation system we will be discussing. That's all. Okay, right. Now when it comes to the cam, okay, now cam is a body which rotates or oscillates, and in doing so imparts a reciprocating motion to a second body called as the follower. Okay, now so we should know that there should be 2 things present, the cam and a follower. Okay, right. Now with which it is in contact. Okay, so obviously the motion has to be transmitted, so accordingly you will be having. Okay, right. Now the length of time spent for the rotation is depending on the shape of the cam. Okay, now the question now is, how are you going to design the cam? Okay, now if you observe the design of the cam, and if you observe the center, okay, it is not a circular. Okay, so if it is circular, you can predict the type of the motion. Okay, now it is something different. Okay, now as you know that when the cam is going to move, okay, so at all the time it is going to make a contact with the follower. The follower will move up and down, and all that thing is going to happen. Okay. So during this the cam follower movement, okay, during the cam follower movement, I think you observe the three different cases. One is called as the fall, other is the dwell, other is the rise. Okay, right. Now, right, when we say about the rise, okay, right, okay, when we say about the rise, so this is the portion of the cam, okay, this is the portion of the cam which gives what is called as a rise. Okay, what is that? This is the portion of the cam which drives the follower upwards. Its profile determining how quickly the cam follower will lifted. Okay, that means let's assume now how the actuation is going to be. Now I am imparting the motion. So this follower in turn will give a motion to some other device. Okay, please understand. We are talking about the actuation. Okay, when we are talking about the actuation, cam and follower is the one which gives you the actuation. Okay, so which is the one? The cam gives the motion. The follower is going to go above. When the follower tends to left, right? When the follower tends to left, it along with this some device has been connected to this follower. Okay, please understand. Some device has been connected to the follower, and when the follower lifts, it also along with the follower lifting, it also lifts the other device which is connected to it, by which it imparts the transmits the motion, and it has done its actuation. Okay, it has done its actuation. Okay, so that is what is the case. Now, when it is going to be in the rise, so there is a lifting is going to occur. The follower is going to lift. Okay, right. Now there is something called as a dwell. Okay, so some portion. Okay, generally this portion. Okay, so this is what is called as your dwell. So dwell is the portion of the cam. Okay, movement, the rotation of the cam, which allows the follower to remain at same lever for significant period of time, and where it's circular with the radius does not change. Okay, now just observe. Okay, so generally it's going to be like this. Okay, right. Now if you observe from here, okay, so if you take the radius of this and the radius up till here, okay, now this case, this is also R and this is also R. Okay, now in this case what is going to happen? So if it starts from here, the radius is going to reduce. Okay, so this moment wherein the radius is going to reduce. Okay, right. Then from here to here, it is the follower which remains at the same level. Okay, same level, actually it is same level for a significant period of time, where it's circular with the radius does not change. Okay, now let's observe. Okay, right, please observe. Now when the lift is going to occur, the actuation is going to occur. Okay, so when it is going to be at the dwell stage, what is that actually is meaning? Okay, remember, every time the movement is not required. Okay, every time the movement is not required. Some portion, okay, of the time should be calculated, wherein you are allowing the machine to do certain operation. Okay, you are allowing the machine to do certain operation. Okay, so that operation, in those operation time, I don't want the follower to move. Okay, I don't want the follower to move. Okay, so in that context, okay, the dwell time is going to be developed. Okay, the cam profiles are going to be made in such a way that you will be calculating what is called as the dwell time. Okay, now I'll just put a simple example here. If you observe, or if you know the concept of a Geneva wheel, okay, please just try to recall. Okay, right, Geneva wheel. In Geneva wheel, what is that you are going to do is you give one complete rotation. Okay, when you give complete rotation, what is going to happen? The link or the pin. There is some pin which is there in the Geneva wheel. Okay, it gets into the slot, which makes the other part to rotate intermittently. Okay, right. Then that is what is called as, that is the indexing part. Okay, that you are done indexing. Then after that small part is rotated, then even if you rotate by another few of the rotation, the driven member will not going to rotate. Okay, that means what? Some portion it is intermittent motion, and some portion there will not be any motion. Okay, so there will not be any motion in that time. Okay, it is called as a dwell time. Okay, during that time the operations are going to be carried out. Okay, now in this case, let's take an example of what is called as your the automatic washing machine. Okay, right. Now in case of automatic washing machine, so we have what is called as a main wash cycle. Okay, correct. We have what is called as a main wash cycle. Okay, we have what is called as a main wash cycle. In the main wash cycle, okay, in the main wash cycle, so we have what is called as a drum, okay, right? The inlet valve is going to be, it should be open till the time it is going to reach a particular level, okay, right? Now we'll take an example of this cam. Okay, now rise is what you do. You lifted the follower. When you lifted the follower, this follower has been attached to the valve. Okay, right. The valve is going to get open. Okay, right. Now it has been lifted. Okay, right. After that, what should be there? It should be there at a particular amount of time. Once it has started to lift. Okay, now let me say at this point of time, it has just the wall. Okay, let's say the wall started to open. Okay, now here if it is going to be the case, okay, the wall started to open. Okay, then it just moves. Okay, now it is just it's a small gap. Okay, assume. Then it just goes further. Okay, right. By the moment it comes here, there is going to be complete opening of the wall. Okay, but you need to leave the cam at a, or you need to leave the wall at a particular till some time, till what is going to happen, till the tank is going to be get filled. Okay, during this position you don't want to operate the wall, or you understand, you don't want to operate the wall. Okay, so now this dwell period is the one. Okay, if you also consider the main wash cycle, only one activity I am talking about. The wall should be open. The walls start to open at this point, and by the time it reaches here, it has completely opened. Okay, now from here to here, that is the dwell period is the one we want the wall to open till the water is going to reach to the maximum level. Okay, after that I want to close the valve. Okay, now what is that you are going to do? You make the follower to come down. Okay, you make the follower to come down. When it comes down, it start to close slowly. Okay, well, when it comes to this point, the closure is going to occur. Okay, it is the start of the opening of the wall, by which up till here, end of the complete opening of the wall. From this point to this point, the valve is still in the open stage. Now it has filled. Okay, then from here to here, you are gradually close the valve. Okay, that is what is the next one called as a fall. That is, the fall is the point that lowers the follower. It's proper determining how quickly the cam follower will fall. Okay, right. Now if you make it too steep, okay, if you make it too steep, okay, right, the radius too steep, okay, then the fall is going to be very quicker. Okay, so depending upon how fast you want to close the wall, you can design this accordingly, and how fast you want the wall to open, you can design this rise portion. Okay, now we need to understand here, so three portion, that is what is called as the rise, then the dwell, and then the fall. Okay, in the rise, the follower is lifted. In the dwell, the follower will be in the same position. In the fall, the follower is going to comes back to the normal position. That is, it will fall. Okay, so these are the three cases which are going to be present. Okay, right. Then we'll go further with the different types of the cams and all. Okay, right. Now this is just a displacement diagram for an eccentric cam. Okay, now you can observe the displacement diagram. Now as and when it starts, and this is going to be your knife edge knife edge follower. Okay, so which makes the contact over here. Now this is the starting point. Okay, when it comes here, so this is the starting point where you are going to start. Okay, right. So this is as and when you give the motion. Okay, now this point. Okay, now you have started to rotate. Okay, once you started to rotate, so this point will come here. The follower as a bit lifted. Okay, when because of the rotation. Okay, because it's eccentric. Okay, you can understand. Okay, because of the eccentric, the radius will be more at the rotation when the next point. Okay, when it comes, so it has come to this point. Then this is the point which is going to come here. Okay, this is the point. When this point comes here, the follower is going to be present here. Okay, when the follower present here, you have drawn the point which is going to be like this. Okay, and next is going to be this. When this is going to rotate, the follower is going, the tip of the follower is going to be at this point. Okay, then you are drawn. Okay, like this, you are drawn. Now, when it comes to this 180 degree, okay, now you can observe here. Okay, very clearly it is drawn. Okay, so this is the path which is going to be there, and this is the point at which the tip of the follower is going to be. Okay, so this is the tip of the follower, and you are drawn that particular point. Okay, so this is one. It is what now it is going to be what is called as this particular duration of the period. Then as and when on the other side it is going to come, it's going to slowly stop, okay, from this point to this point. Okay, now this is a just an example of what is called as a displacement diagram for the eccentric cam. Okay, now we have different types of the cams which are going to be there. Okay, now I think I just have some point to discuss with you. Okay, that's why I'm just closing 10 minutes early now. Okay, so during the discussion, you please type your USN number in the chat box. Okay, we'll stop at this stage. Okay, so what we have done today is the kinematic trains we have done. Okay, kinematic train, and then understood about the links and the nodes. Okay, then about what is called as your this four bar mechanism and the slider crank mechanism we have discussed, and then just go away from the what is that, the recording option. Okay, so this is about this.